Question 3. What is the wavelength in nanometers of a blue light having a frequency of 8.6 times 10 to the power 13 Hz? So we've been given the frequency to be 8.6 times 10 to the power 13 Hz. We need to determine the wavelength. So the formula we're using, energy is equal to HV, where V is our frequency. Now we know this formula can also be energy is equal to HC over wavelength if we're dealing with wavelength. Now this time around we want to find the wavelength. We've been given the frequency. So if you had to equate these two formulas and relate the frequency and the wavelength, you see that this is HC, this is HV. So since these are equal, right, we can equate what is on the right. So the formula is going to be HV is equal to HC over the wavelength. So that's common. So therefore frequency is equal to speed of light over wavelength. I already showed you this equation. This is the equation that relates the frequency and the wavelength. So for the very first one, first to determine the wavelength, we can just make the wavelength the subject. So it's going to be C over the frequency. So speed of light 3 times 10 to the power 8. And then over frequency 8.6 times 10 to the power 13. Okay, so whatever we're doing, we're using the standard units in, so it'll give us meters because the speed of light is in meters per second. So 3 times 10 to the power 8 divided by 8.6 times 10 to the power 13. Okay, my answer in scientific notation is a 3.4. So I'll take it to 2 decimal places. Looking at what we have there, I'll just hit 1 decimal place. So 3.5 times 10 to the power negative 6. Negative 6 what? So the units are meters. So we want the answer in nanometers. So you know that in nanometers you can just basically multiply by 10 to the power 9. So if you multiply by 10 to the power 9, so we'll have 3.5 times 10 to the power 3 nanometers. Okay, so if we are to have it in a normal form, actually it's going to be 3,500, but we can leave it there. So 3.5 times 10 to the power 3 nanometers. Okay, and then for the other part, they want us to find the frequency. So frequency, speed of light over the wavelength. So we need to take the wavelength in meters. So we have to multiply by 10 to the power negative 9. This is the difference when you are moving from a bigger unit, which is a meter, to a smaller one, nanometers. You need to multiply the meters by 10 to the power 9. When you're getting back to meters, which is bigger, you have to divide 10 to the power 9, which is as good as multiplying by a negative power. So 3 times 10 to the power 8 divided by 566 multiplied by 10 to the power negative 9. So the answer I'm getting for frequency, 5.3 times 10 to the power. So this one is actually to 3 significant figures. So we can have 5.30 times 10 to the power 14. So frequency, that's in Hz. So this is how you handle this question. Simple and straightforward.